Thank you so much, and I'm really excited. Thank you for inviting to give my talk in at the Global AI Tour. As It's covering like 10 different locations, 48 hours of like live streaming, so many speakers, so many great talks. Very exciting, actually. So, as I will give my introduction a bit later, but my today's talk end-to-end data and AI platform designing in Azure. So whenever we hear any kind of AI or data science based talks, either we see like some kind of like sales pitch or some kind of like small POCs or some kind of like small technological aspect. But today, what I want to like talk about is from an end-to-end data and AI platform, from an enterprise point of view, what are the components that we need to succeed in this field, and how can we leverage all the great tools that Azure is offering. So we will look at those small great offerings as well, and how it's synergizing with our need, and how can we do those great stuff. So, in short, the agenda will be enterprise data and AI strategy. If you are thinking to establish your strategy for your organization, what are the things and how can we work together, from an organizational point of view? What are the end-to-end data and AI platform components and tools you need to have? When we talk about data and AI, it is actually a bit different than software development lifecycle. So how data and AI lifecycle works, what are the components, what are the key personas and roles we need to have in our team or organization. And we will also talk about Azure data and AI services, ideal data and AI components that will cover or complete the data and AI loop. So before I jump into my presentation, if I just talk a bit about myself and my background, I work at CAE in Montreal, Canada, as the data and AI platform architect, and it's been like so many years. I'm working in this data and AI industry. Been involved in so many AI initiatives, like in different workplaces. And my background is obviously studied in IT, AI, and it's been like 6 years that I'm a Microsoft MVP in artificial intelligence. Okay, so before we jump in to see all the technical stuff, let's see a bit more. Why do we need AI and why do we need data? Uh, like if we look at some of the stats, then we can see that by 2025, AI market will be $60 billion, which is the only $1.4 billion in 2016, and it's growing literally exponentially. And AI can actually increase your business productivity by 40%. So it's not just like for a single like one or two domains or one or two industries. It's applicable to all industries. So you can ask me how. So it's like with AI and data science, you can learn more about your existing offerings. You can learn more about your existing customer base. You can offer new services based to be ahead in the market than your competitors, and those services will be data driven and data centric. You can identify where are the issues that you're facing, where are the gaps based on the data that you're collecting, and then addressing those issues. So literally, you can increase your business productivity, bring those automation by 40%. And another interesting trend we have noticed recently is COVID. Because of COVID, most of the industries been impacted largely. A lot of like layover, a lot of fund cut. That like those things have happened. But in case of data and AI, it's a bit different. What we have noticed that AI industry has got more investment during the COVID time, because the industries are like realizing we need to invest more in automation, in less manual work. We need to bring more data driven decision making. So that's where AI is getting more focus. So from a platform or strategical point of view, in an enterprise level, when we think, okay, we are this is our organization, we want to take it forward, we want to set up our AI strategy. How would we do that? Is it just like get into the cloud, set some like POCs, that's it? No, actually, to leverage the actual benefit of data and AI, we need to do a bit more than that. So that's why I am giving like a couple of slides before jumping into the actual data and AI components. I'm going to show how we set the data and AI platform strategy. So data and AI like are not like in individual components. They work together. So you need to have a synergy together. So you can see you need to first ensure data process or data sources. You need to have data source, data lake, data ingestion process, cold and hot storage, data processing. Once you identify while you are doing like establishing your data platform, you also need to like have your knowledge and skill base of data science, analytics, dashboard, and artificial intelligence based skill. And like this too, when you establish your data team knowledge and skill within your organization, then at that time you need to start to work on your information context, which is data and AI platform, which is synergizing these two together. Your information management, your data flow or information architecture, your security and governance. The moment you set like establish these three pillars of data and AI, data, knowledge, and information context, you will get benefit from understanding your organizational needs. You can establish your data culture to take data centric and data make like database decision making, following the proper governance, and also identify proper insight of your business and get proper ROI, return on investment. That is what will help you this kind of like proper structure for data and AI centric strategical decision making. So it's not just having AI or just having data. You need to have all three together to like get the most out of it. And when we and it doesn't happen in a day or in one quarter. It needs some investment, and it needs like some back and forth planning and work as well. So we look at this pyramid usually to be a like a data driven organization. So when you cannot achieve a data centric and AI driven organizational status from the first day. First step is collecting all the data, setting up proper data strategy. Then data you have all the data, but you need to know what is the value of this data. Like having the data doesn't make any like doesn't mean anything. You need to identify get insight from that data. You need to make get information from your data, identifying KPIs, setting up the platform. Then while you're doing it, you need to have start to do data based data driven AI POCs, proof of concept. While you do those POCs, you get the information, you set up the KPIs, you will see that there's a bunch of like gaps. You will identify those gaps. You need to like do it properly. You need to do the data management, data governance, and from there you will start to like, okay, we have the data, we know what are the information we can get from the data. Now how can we start to get some revenue from the data and AI that you have worked in phase one and phase two? From those like revenue generation based strategy or application, you will see that okay, there were some of the approaches were wrong, they were not complete, and you will have that understanding in approach 4, in phase 4, and you will reiterate that same approach based on the learning that you will have in the phase 3, so that you can like get into a better situation with the experience you gain, and you set up your return on investment. It's not like you will just invest, that's it. You need to like identify how much return I'm getting, and from that understanding, from that reiterating the process, you will get into the insight of actually finding all the values, KPIs, data driven decision making, learning and understanding from your data, and like do like thriving your business from your data. So that's how the pyramid works. Having the data, finding information from the data, getting the knowledge of all the information and the data, having the understanding, okay, where did you do wrong, and fixing all these issues to be into that insight phase, to be a data centric and AI driven decision. So it works in like a complete loop. Now the thing is, as we are talking about data and AI, what are the like components you need in to establish that kind of like platform to be on like to start that like complete pyramid of all those phases. So in this data and AI, I will separate it into two phases. First, I will talk about data. Then I will talk about AI. So in the data platform requirements and components in Azure, you can see if we talk about key personas, how the data lifecycle works. So these are the like key roles: business leader, architect, data engineer, data modeler, visualization, and data analyst and scientist. These all the key roles are extremely necessary to complete the data platform or data personas like loop. So first, before anything, you can like you need to identify your business like set you need to business goal with your business leadership team. This is the first phase. And then your data architect is the one who is going to review and create data ingestion like architecture. What is the like where are all the sources? How would you ingest the data? Where will you recite the data? What is the process? Is there any security issues or not? So it's the job of your data architect. Then your data engineer will work to build the data ingestion pipeline, to build that process, to bring the data to your environment. When you bring the data, your data modeler will start to work to on the data, so that you can do data modeling of this data, changing, doing different kind of like schema, different kind of like manipulation of the data, so that you can have data reporting and data like visualization, so that the business leaders can see all the reports from the data in live, and get the KPIs from those data to take the decision. And also in this phase, data visualization and reporting developer works with the data modeler, so that they can build it, they can deliver it, they can ensure and check the quality of the data, identify the KPI check, and find out the inside of the data. And from the data modeling phase, the moment you ingest the data raw and doing all the data transformation, modeling, finding out all the KPIs, that's where your data analyst and data scientist like plays their role. So to do all the like data modeling, data science, like data science based application development, any kind of like data cleaning, processing, transition, it goes through them. So these are the like necessary key personas that we see in a data ingestion life cycle. So leadership, architect, data engineer, data modeler, data visualization, reporting, and data analyst and scientist. So during this end-to-end phase of all the like key personas and life cycle, the components that we see in a data platform is the first one is data ingestion. We need to ingest the data. Then we need to store the data. We need to transform the data into different phases or in different zones. We need to like do data reporting and visualization, because you can have the data, but you need to generate some kind of values from the data, or look for different patterns of from the data. You need to do data consumption. You can also do data governance, and money management, so that the data is secured. Data is not accessible to everyone. The data proper rules and regulations of GDPR, ER99, data control goods, all those data privacy rules are maintained. And also, the data is democratized. Data is accessible to all your developers, so through sandboxes or different marketplaces, so that you can check your data quality. You can do innovation through your data. So these are the high level steps that you need to have in your data platform. It's not just like having a database. It's something more than that, to enable your organization to be that data driven. Now, how those components are like actually like organized. So that's how the components are established together. So as we said, like there are like a few phases. First phase is data ingestion, data store, data process, data serve and enrich, a bunch of use cases, and data discover and govern. So on the data ingestion, you need to see the migration is happening of the data from existing data sources, existing system application, or from one region to another, that kind of like database migration. You will have a lot of sources where it's like IoTs, where you may have to like do real time ingestion, or you may have to do near real time or batch processing based data trigger or data pipelining. So all those data bringing or data ingestion is in this phase. Once you bring the data, you need to store them. When you store them, you will see some of the data are structured, some of the data are unstructured. They could be flat files, or they could be relational tables. So you need to keep those in your mind. You also need to have hot storage and cold storage. You should not like store all the data, keep all the data in the hot storage if you're not storing them, because yes, you design the data store, but do you need to have all the data all the time? No, you need to have archiving process. That's where the hot and cold storage comes. You need to have data storage zones. So it's actually connected with the data process, because when you ingest the data, it is on your raw zone. Then you can do some kind of business like hard rules, that the moment you have the data, you need to do some kind of processing, some kind of joining. So that's where you after doing those processing, you keep them in the silver zone or transient, or that kind of any kind of naming that you follow, silver zone. And then you can apply your soft rules or business rules based on the data of from based on the data source. And it's also use case specific. And that's where after doing this processing, when you keep that data, you call it like curation zone. So raw data, then applying hard zone, hard rules to keep the data in the move the data to the silver, and then applying like business rules or soft rules to move the data to the curation zone. So that's how the data zones work. And while you're doing that, you need to ensure that data security, that if the data has PII or health information, it should not be accessible to everyone in the within the organization. Who has access. If you are exposing the data for a lot of use cases, you need to mask those personal information. You need to know those things. And also the database KPI. So as I said, not all data has values. You need to identify what is the KPI of this data that you are putting it ingesting, so that the data is not just like sitting in your shelf. Data is properly used and leveraged. After the storing, then there is the data process. So based on the structured data or unstructured data, you want to expose the data for different kind of reporting and visualization. So you do some kind of schema, star schema, or different kind of processing of the data to expose it. You can expose it through Power BI or any kind of like dashboard. And during that phase, you also I also said the data transformation on different zones. You sometimes do data wrangling, so that the data is well processed for the reporting and dashboard, or any kind of like data analysis or machine learning use cases. The data consumption is happening to other systems for in your consumption layer. Sometimes you need to keep it as well, so that the data that you're ingesting is ready to serve to other systems or other application or reporting cases. And data recipe repo. So every time you are doing those changes to your data, uh, you're changing from level 1 to level 10 of the same data. You need to have a data recipe of repository of your all those data changes of those recipes, so that you are not losing the process. You can go back to level 4, level 5 changes, and reproduce the same steps. And the last part is data serve and enrich, which is sharing the data throughout your organization, sharing the for the different kind of data consumption, doing data and ML related operations, doing BI and analytics, exploring or exposing the data through a sandbox for data democratization and database related innovation, having data marketplace, so that all the data that you're ingesting is properly visible to all the business cases or business domains. And you are also implementing machine learning based use cases of your data. So this is mostly serve and enrich section. But underneath, we have the data monitoring, alerting, administration, that the data that the pipeline that we are setting is ingestion is happening properly. The data is like following proper quality. There is no issues with regarding the administration, bringing the data, and all those like data ingestion related phases and data processing related phases. The data governance, access management is well maintained, and all those things are in a cloud platform. So that's those are the components that we'll usually look for from an enterprise point of view in a data platform. Now the question is like Azure is offering all the components that we need in an enterprise platform. So let's look at that one. So this is a reference architecture provided by Microsoft from an Microsoft Azure product point of view or tool point of view. So you can see on the left we have all the data sources. Sometimes they're streaming, sometimes they're unstructured, sometimes they're semi-structured, sometimes they're relational or different data services. So when you are bringing the IoT data or streaming data, you can use event hub as an event driven approach, or IoT like hub as your IoT hub for streaming. You can use for processing, you can use from event hub or IoT hub to stream analytics to bring the data and uh, also feed a Power BI dashboard in real time, or serve it to cognitive service or Azure machine learning based models to find out different kind of pattern from this real time data for alerting or IoT based applications. And at the end, from Power BI, you're exposing the BI based analytical service for your business unit. You are offering that side. You're covering that side using the using Azure. Now, if you have unstructured data, semi-structured data, or like relational data, then how it works? You can use Azure Synapse Analytics pipelines, or you can also use Azure Data Factory to have set up different kind of like pipeline and trigger to bring the data and like put it in your Azure Data Lake Gen 2. And on your Azure Data Lake Gen 2, you can have multiple containers of different like zones, raw zone like bronze, silver, or gold zone, or raw zone, transient zone, or like a curated zone, in which you will apply your keeping your raw data, doing your like applying your like hard rules of your business, or apply your like soft rules and separate all those data in different zones. And while you are doing those processing from raw zone to like a bronze zone to gold zone, you can use the like Azure Synapse Analytics dedicated SQL pool and Spark pool as well for all the processing that we already said you need to do in your within your data platform. And those components are mostly serverless, so it's also like very like cost effective, and it is also offered by Microsoft platform. While you're doing it, you can expose like your data like after doing all the processing through Power BI for reporting or dashboard or analytics purpose. You can also expose your data, process data, like in data warehouse or that kind of like relational format uh, to Cosmos DB for application serving or application consumption. You can also keep it in an data share or data mart based serving approach for shared databases, and all those like offerings you're getting from Azure. And underneath you have Azure Purview for data discovery, data management, and data governance. Who has access to it? And it works with Azure Active Directory. You have your cost management, you have your key vault, Azure monitor, and all those like other cool Azure components. So the components that we see in an enterprise point of view for data discovery, for machine learning approach, for real time or like batch processing, for structured or unstructured, for serving. All those components are there within this single like cloud like technology or cloud platform. So you can just use them and leverage based on your need. And if we talk about AI, there's some like small things, but again, like I will like talk a bit more details. Those are the things that we see in a data platform. Now let's see what we see in an AI platform. Before we like jump in to an AI platform point of view, so AI is a big topic. So it's artificial intelligence, but underneath as a subtopic, we have a subdomain, we have machine learning. Then the subdomain, another subdomain of machine learning, we have deep learning, and which is also like connected with on overlap with data science. So all of them together, we call like artificial intelligence. So if we see a bit detail, like how the AI lifecycle works from a key persona and like the business point of view. So these are the like key roles for AI actually. So first, you need to set the role like a goal by the business leadership. Then the data engineer will play the role to bring the data, gather and prepare the data so that there is the data. Without data, there is no AI application. Then the data scientist is the one who will work on the data that the engineer has brought and develop machine learning model based on the data that they have got. Then there is machine learning engineer. They will work with the data scientist to do all the ML ops practices, set up the proper pipeline, service principle, like end-to-end process, and do the testing, production platform development. If you are doing during the development phase, creating those dev environment, hosting those model, testing them, doing those all those like massive testing, load testing. Do you need GPU? Do you need CPU? What kind of how do you host your model? Those things will be done by machine learning engineer, and they will be the one who will deploy the AI model. You can have the best AI model like in the world, but if your model is not like usable by client application, then there's no point of like having that model. Like machine learning engineer is gonna deploy the model, and they are also gonna work with the app developer who will take the model, connect it with different apps, web, mobile, or that kind of apps for inferencing. And in most of the cases, there are like two ways of AI model deployment we see. One is batch processing, and another one is real-time processing. If you need to like in case of batch processing, you can use like some kind of like end of the day batch processing, bring all the data on batch, run the model like for a certain time, update all the records that you have. Or if you get like a microservice based approach where you get like a single request from your web and mobile application, and then do some kind of like a call the rest endpoint, which is used by or exposed like for the AI model, and then generate the prediction and send the prediction to your like mobile app. So that's why you need to your app developer and machine learning engineer should work together to identify if there is an issue or not. The model is properly exposed as a inferencing endpoint, and your application can actually use it and handle that much load. And also you can design the model, deploy it, but you need to monitor the model as well. You need to manage do model management, because yes, you have uploaded a model, it's on a single container, and it is processing like 10 requests per minute example. So if you are expecting 100 requests to process by your application per minute, then you need to have 10 replicas of the same model. You can use Kubernetes cluster, that kind of like approaches, or some kind of like serverless approaches. But you need to like test them, do load testing, resource allocation, manage the model that you're deploying. So that will be done by machine learning engineer. And the model monitoring, obviously, identifying the data drift, performance monitoring will be done by data scientists. And the last part is IT operation, which will be like supported by everyone, like the IT team. So you see, from an AI machine learning lifecycle and key persons point of view, you have business leaders, data engineer, data scientist, machine learning engineer, app developer, and IT operation, all of them working together. So it's not just like designing one simple POC and it's working on my laptop, done. No, it's when you are like doing an enterprise level, it's way more than that. And there are some new roles that has been emerged in last few years, which is like data ops and ML ops. So it's kind of like the DevOps of data and AI. So I just wanted to give like a small brief on that one. When we talk about like application development lifecycle, we mostly use this term of DevOps for CI/CD implementation, for ensure greater collaboration of different teams, to like have like a speedy and stable development and deployment, hosting platform, and working in application platform and infrastructure level. But as data like an AI lifecycle is different than software development lifecycle or application development lifecycle. So the same thing that DevOps is doing for data and AI lifecycle, it's data ops and machine learning ops. So it's the DevOps on data and AI. So data ops ensure automated process-oriented methodology used by analytics and data teams to improve data quality and reduce data bringing or cycle time. And MLOps is the same approach for like data, but they ensure the deployment, the monitoring of the AI model, the reproducibility, or keeping all these traces of every single step, scalability of the AI model, and while ensuring continuous training, continuous integration, and continuous development pipeline. So that is ML ops and that is data ops. These are the new two methodologies and new two roles that has emerged over the years. So we need to keep them in our mind too. And before we jump in, so usually we see three types of like AI applications or like based on data categories. One is category one, text and number, mostly classification, regression, time series, recommendation, that kind of like use cases of AI. Second one is classification like data category two, which is audio, kind of like NLP or conversational or text processing, that kind of like approach. And the third one is image and video, which is image processing, like object detection, facial recognition, image image matching, that kind of approach. So any kind of AI application is like actually following one of these data category, category one, category two, category three. As we talked about our data platform lifecycle, AI lifecycle, now we will talk about data modeling process. So how the data modeling works actually, because we hear like we do some kind of like model training and some kind of magic. If we go a bit more detail, don't get scared with this diagram. I will bring like break it. So we have the data set first, and sometime based on the data that we have, if we have so many columns, it's like thousands of columns, and we want to like, okay, the dimension of our data is too big. We apply some kind of like PCA, principal component analysis, LDA or SOM, to do exploratory data analysis or reduce the size of the like of the dimension of the data. But other in other cases, we can avoid that side. The first step is from the initial data set, we do pre-processing of our data, which is data cleaning, data curation, remove redundancy, handling missing data, do imputation, do categorical encoding of our data. So which turns into like which becomes our process data. This one, which looks like something like this. All those like x1, x2, x3 columns with like a target of A and B, if it is a classification model we want to build. Then we divide that data into phases from a model development lifecycle, which is like training set, testing set. Sometimes we also keep a validation set. So it's like 70%, 15% validation, 15% testing. So here 80-20. Then from the training set that we have of 80% of our data, we do modeling. We need to find out, okay, what are we trying to achieve? So from this data, if it is like a classification that based on that data, we want to predict it's class A or class B, it is classification algorithm. So we need to select the classification algorithm. So there are so many algorithms in the market, SVM, like XGBoost, or if based on the type, KNN, like deep learning, or like GBM, a lot. So we need to know what is the problem type classification. Then we can select the like algorithm. When we select the algorithm, like different algorithms have different hyperparameter. We need to do hyperparameter optimization to find out the best combination of parameter for this specific data like use case to get the best result. We also do cross validation for on our trained training approach, so that we always get the like non-biased and proper, the training happens in proper way. So once we design the train model, we train the model with the proper algorithm, suppose XGBoost in this case, and then we have the train model. Then we take our testing model to test the result of our train model, to see how good or bad the model is, how well we can predict class A or class B from the testing data set. And we also do different kind of model evaluate a model performance through a different kind of matrices of classification algorithm or regression algorithm. So this is a like a classical machine learning lifecycle works. Get data, process it, select the type of the model, select the algorithm. You can also use automated machine learning to select, to apply all sorts of like a model on that specific use case. Apply hyperparameter optimization, select the model, test it, do your prediction based on evaluation of your model. So that's how this end-to-end data modeling phase works. Now, if we look at the model training to deployment phase into a machine learning pipeline, how it works. The first one is loading the data. Then we do all those data processing steps that we just talked about: curation, data wrangling, data transformation, validation, data featureization. 70% of our success of our model depends on this phase. And then you select the type of the algorithm, the problem, classification, regression, those things. And then you select the algorithm, which algorithm you want to use. You do the training, you do the hyperparameter optimization. Then you test your model with the testing data set. Then you validate your model. Yes, I'm convinced that this is the model I'm gonna put it in the production. Then you deploy the model. You take the binary model. You have the YAML file to create the same kind of like environment of your training, so that on the during the testing phase or inferencing phase, you can create the same container the same way. You also need to have a scoring file. So a scoring file, a YAML file, and the model file. You take these three files, create a container, put it, wrap it in an API, host it in the cloud platform as a RESTful API service, and expose it to your web and mobile application, so that your web and mobile application can do a RESTful request with a JSON, and your scoring file take that JSON from that request, process those process the JSON data, break it into like a data like consumable manner or format, give to the AI model. AI model takes the data the JSON or the whatever the approach the format the data that it is receiving, process it, create the prediction, send the response as the response of the API. So that's how this approach works. And then you can also do batch process prediction. You also need to do model monitoring. What is the runtime? How long it's taking? Do you need to have more replicas of the model, and those steps? So this is the model training and end-to-end approach. So from that point of view, we see what are the components that you need to have in your AI platform is you need to your AI platform needs to have some kind of like pre-trained network. If you don't have the data, but you want to apply some kind of common use cases of facial recognition, like text to speech, like your AI platform needs to have those pre-trained options, so that you can just use it, call the API and use it. Your AI platform needs to give your machine learning training approach or training platform, where your machine learning developer data scientist can use Jupyter Notebook, automated machine learning designer, or data science virtual machine to do all those training approach. Or your machine learning a platform should give you CPU or GPU computational components as well. Your machine learning platform needs to give you the option both training and inferencing computing cluster from container and Kubernetes cluster point of view as well. Your machine learning platform should give you the tools that you need for data annotation for the training purpose. And also, your machine learning platform needs to have the mlops, the continuous training, model testing, monitoring, data drifting dashboard, those like two components. So that's a lot of component. If we look at Azure now, what it has, it like literally has every single component that you need. It is offering us pre-built AI, which is cognitive services for facial recognition, language processing, knowledge understanding, those things. They're already there. You just call the RESTful API and use it. You are also using a bot framework. You also have the option of using custom AI for image processing or that kind of training. You're getting Azure Machine Learning based Studio for training, ML Workbench, or even like different kind of like deep learning framework for cognitive toolkit, TensorFlow, Cafe, PyTorch. And if you look at the data, you have the data lake, SQL, Cosmos, and also you have all the other computational or infrastructure related stuff. So all those components that we have seen that you need to have in your platform, as you have them. From a machine learning point of view, as your designer, Jupyter Notebook AutoML, it's covering your automated machine learning or your custom machine learning approach. Your cognitive services are giving you the all those like pre-built option of machine learning use cases. Your custom modeling approach is giving you completely model development from scratch using deep learning models on Azure Compute if you want to do it by yourself. Um, your conversational AI or bot framework is also giving you that option. Plus, also you're also getting the benefits of using Databricks, Azure Databricks on a PySpark, Spark ML for big modeling jobs. So all those components are already there. You won't have to do anything extra. So the moment you have your machine learning model, you write your code, you do your data sanity test, do your unit test on your data. You're comfortable. Create your machine learning workspace in Azure. Create your machine learning compute. That's the next step. Publish your machine learning pipeline based on the data and all the codes that you have written. You push it to Azure Machine Learning training, which trains the model. Then it also helps you to evaluate your model. If you're comfortable, or if you want to test your model as an API, you can register the model in Azure Container Registry, push it through Azure Machine Learning Model Management for like to make the model as a like package a model into an image. You can deploy the model for staging or development like environment on ACI, which is Azure Container Instance, to test the model in during the testing phase. You can test it as a web service. You can also, once you're convinced that yes, the model is performing well, I'm ready, the training has been done well, then you can push it to Azure Kubernetes service. You can deploy it, and you can scale the model in lots of pods so that your model can handle that much request. And you can also see Azure. You can use Azure App Insight to monitor the performance of your Kubernetes cluster, how many requests it's processing. If you do the training using Azure Machine Learning, there is option for data drift. You can also use it, and also you can store all the model result prediction in your storage. So all those end-to-end approach is actually offered here, and you won't have to do anything extra, which is covering the complete platform. So which is actually great. As a data scientist or AI developer or architect, we won't have to do anything more. So long story short, if I just give a couple of like the last example of model development, you can ingest your data in your data lake, do all the processing with the data factory, Synapse Analytics, with your data bricks, and keep the data in different zones of your data lake, expose the data in your SQL warehouse as well if it is a relational data, and or like for different kind of like dashboarding, power automate based approach. You can apply cognitive service machine learning approach in your data. Once you're comfortable, you can register your model in container registry. You want to test your model, you can push it to a dev environment in ACI. You want to push it to a production, you can push it to an Kubernetes service, like to scale the model. You can serve that API endpoint of the model to and connect it with like web app, mobile app to connect your model with all the client-facing application. You can store your production database of your prediction generation in your Cosmos DB so that you can check the performance of your model, all the other insight that you need to do, or you can bring back that data for retraining purpose, create automated pipeline of your model. And also, if you're doing the batch processing, you can always use a Databricks based batch processing or batch ML. There is another component in Azure. You can also use that one. And there is a Power BI for a different kind of like analytics service. So one platform in Azure is giving you all those data components, AI components that you need to design that end-to-end enterprise-graded data and AI platform to be a data-driven and data-centric or AI-powered organization. So that's it. That's a lot of information actually in 45, 50 minutes. I tried to cover as many like aspects as I can from like mandatory components that you need to have in your data, mandatory components you need to have in your AI platform to to give the all the tools that your data science, data engineer, AI developer, and business needs, and look at and gave you example of all the components or tools offered by Azure that you can use and leverage and complete your end-to-end platform. That's it about my presentation. Thank you so much. And if you want to like contact, if you have any question, feel free to ask me. If you want to like connect with me on LinkedIn, feel free to do that. Thank you.